Hello, I'm Dr. Ron England, and welcome to Programming for Engineers. And today we were going to talk about arrays and interpolation, which is essentially going to be our example for arrays. The course is EGN 3214 if you're curious, but let's get right to it. So the concept of an array. Now you should understand the concept of a variable. The concept of an array is not much different. An array is simply a bunch of variables put together essentially into a single variable, and they're indexed variables. So for example, we look over here, if we had a series of numbers like 0, and these are, by the way, are the indexes, and a series of numbers we wanted to keep indexed, that would be an array. So x of 0 is 0, x of 1 is 0.04, and these are integer indexes. However, we're going to have to work a little bit beyond that concept of integer indexes because we're going to have situations where we need to actually find values that are between. That's where the good old interpolation comes in. So for right now, we'll move that out of the way and we'll just start going into the programming example. So if you look at those numbers, I've assigned them to an array by essentially saying rain, which is going to be the array. This is just, let's say, an array of rainfall values. Is equal to 0.00, and then these numbers comma delimited with a bracket and a bracket. And if I run this, I will find that it spits out print rain of 1, 0.04. And the reason for that is the first index is 0. So if I were to say print rain of 0 and I ran this, it would spit out 0. Okay? If I put in rain of, let's say, 5, it would spit out spits out 0, 1, 2, 3, 4, 5. It spits out the 0.95. And if I were to put in something that was beyond the scope of it, it would give me an error saying that the last index is out of range. So that's pretty simple stuff. That should not really confuse anybody. I've got this ability to put the numbers into an array and then go in and look at the values in that array. So I'm going to get rid of this print right here. We're going to start doing some playing with this array. So the first thing, I've gone ahead and I've made these so that I could copy and paste them in here. The first one I'm going to do is the for x and y, or in this case, for r in rain. What this is going to do is it's called a loop, a for loop. It's very, very common, the good old for loop. But what it's going to do is it's going to go for each value of these numbers in this array. It's going to execute this series of statements. So it's going to set r equal to 0 and then do this stuff. Then it's going to go set r equal to 0.04 and then it's going to do this stuff. And it's going to set r to 0.11. It's going to do this stuff. Okay. Now what we want to do here is we're going to go ahead and we're going to try to find the first r value that's greater than a value that was input by the user. Well, the problem is we haven't input anything by the user, so we need to do that. Y is equal to, now, if you remember my last lecture, I used the int. Well, this time I'm going to use I'm going to make sure that the y variable is a float. And I still need to use the input, and I'm going to say input value for y, okay, colon, space, dump. Closes the whole thing up. Now, for those who are wondering, notice I am not using Notepad++ this time. And at each lecture, I'm going to try to introduce you to new tools. The tool I'm using today is called Thonny. It's an actual environment specifically for doing simple and basic Python programming. It's not really used for large-scale programs, but it's great for doing little tiny programs. Now, I've actually now said let's input a y. The y is going to be a float using the input command, and I've got a prompt, and it's going to get a y now. It's going to go in and go to the r equals 0, 0, and it's going to check to see if r is greater than y. Well, the first rain is 0, and if I input a y that is greater than the r value of the first one, it's just going to do nothing. But when it gets to a value that's greater than when it moves through this, when it parses through all these values and it finds a value greater than y, it's going to say we found it, which is basically this print here. Notice something else that I did. Print first r value greater than y, bracket bracket is bracket bracket dot format yr. Remember in the last lecture I said you don't have a way of actually putting the numbers on the same line with the string. Well, guess what? Now you do. Let's run it and see what happens. Okay, so it's going to say down here at the bottom, I'm going to move this up because I got plenty of room up here. I'm going to make this a little bit bigger here so you can kind of see this. Input value for y. Okay, so now the input value for y, let's just put in 0.15, enter, and it says the first R value greater than 0.15 is 0.6. And if you look at it, doop, that's not greater, that's not greater, that's not greater, that's not greater. The logic should make sense. It parses through, it checks to see if R is greater than y, and if it finds an R greater than y, it tells you, hey, I found it, here it is. All right, so now you've seen a for something in something. Well, let's go on and do another example of the coding piece of this. I'm going to move this back down a little bit. So, let's see if I can grab it and bring it back down. Okay, now, I have gone ahead and made it so I can go through fast. I can just copy and paste this baby right over here. Now, look at this. I've got another function, the range function. What this is going to do, and notice I changed R to I. I is just typically used a lot of times as a counter for I in range 0, 6. What it's going to do is it's going to go, I is 1, do this. Or I'm sorry, range 0 to 6. I is 0, do whatever's in here. I is 1, do whatever's in here. Move to I equals 2, do whatever's in here. So in this case, remember up here, I had where I could actually print out the reign of I, the index. Well, now I can actually use it in an if-then. So reign of 0 should be 0 up here. Reign of 1 should be 0.04. Reign of 2 should be 0.11. So now I can check to see if the reign is greater than y, and then I'm going to output the y in the reign of that. Should do exactly the same thing the first one did. Let's try it. Whoops, syntax error. For I in range 0, 6. Oh, my indent. This is one to definitely get used to here. Spaces and tabs. Whoops, spaces and tabs are not the same thing. And a lot of times when I copy paste, if you notice I had spaces there, they're not tabs. Oh, it doesn't like this one either. Because, and this is one that you definitely want, and this is one of the frustrating things with that you're going to find with Python is getting all your tabs to work correctly, or spaces if you use spaces. So I'm going to make sure that I got everything here. And one of the reasons this happened was because I copied and pasted it. Notice that tab, 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 tab. Okay, boom, and whoops. Boom. And okay, it still does not like the outer indentation level. Well, here's one thing I'm also going to do, because I could have an issue right up here. Oops, I do. Okay. Okay, I'm going to go ahead and get rid of this piece right here, because I don't need it anymore. It does the same thing that I already did. And oh, and look, see the 4? I got a space there. Darn, darn, darn. You can see that can cause a big problem. Good that you saw that, because now you can see that that indentation can cause you problems. Now if you notice that I went through it one last time, and this time I had all the indentations right. All right, so I'm going to go ahead and enter like 0.15, and it did the same thing it did before, only it did it differently for the I in range 0 to 6. And you got to see the issues that you might run into with indentation, and that was all just caused because I had a space between the left column and the leftmost column and the 4. Okay, well, now we've got it. First R value is y greater than y of 0.15 is 0.6. It did exactly the same thing it did before, and now you've seen the whole thing with the range. All right, well, let's get rid of this guy here. I'm going to actually get rid of it, and I'm going to come bring another one over that we're going to play with. Okay, now hopefully I won't have the same problem with my copying and pasting here. It looks like I'm okay. Now, in this case, what I'm going to do is I'm going to show the bounds by using the, in other words, I'm going to look for the lower and the upper here, so you can see how that indexing works. Now, what am I saying here using the lower and the upper? If reign of I is greater than y, same thing we did before, that means that the value to the left of y is the reign of the index before it, which would be I minus 1. So you can just put the equation right in there, I minus 1. So in other words, if I find that it's greater than, this is 0, this is 1, this is 2, well, let's just run it. It's easier to see that way. I run it, I input a value 0.15, and it says y value 0.15 is bounded by reign value 0.11 and 0.16. Well, 0.11 would be this one here, but I did it based on the so it's 0.11 is this 0, 1, 2, so this is reign of 2, and 0.6 is reign of 3, so it's reign of 3. Well, maybe we should actually look and see what those values are of those indexes. So let's take this one out. Bye-bye, you saw it, you saw it. Now let's go ahead and bring in this one well, let's just go one step further. I'm going to go one step further here, and I am going to have, whoops, there's a space there. I'm going to go ahead and get rid of the y, and let's just look at the indexes. Let's enter the indexes. So now I'm going to say x is float, input, enter x values as index 0 to 6. Now I'm going to do for the range from 1 to 6, and I'm going to actually look and say the x value, I'm going to look for that bounds, but now I'm actually putting right over here the I minus 1 and the I, the actual indexes. So let's do that. Let's run it. Let's do, let's say x is, now because I made it a float, I can make it between stuff, and I'm going to be looking for the indexes. So now if I do 1.5, well, the 1.5 should be bounded by 1 and 2, the index 1 and 2. Now I could also give you the values of the 0.04 and 0.11, which would be the reign of 1 and the reign of 2. That takes me to one step further. What can I do with this? I have been able to find, now if you see the way that I'm actually making the array work, I have an index, okay, and I'm going to pull that back up so you can visualize it. I have the concept of, and I got this over in Word, but I have the concept of an index, which is this column right here, and I've got a concept of a value, which is this column right here, and the array is simply the integer indexes correspond with something in the array, but remember I put in a value that wasn't an integer. It was able to find that it was between this index and this index value. Okay, well, let's see. If we've got an equation for interpolation, I should be able to give you what values that are interpolated between the two indexes. Well, let's see if we can do that. Okay, you saw this guy working. It's not terribly tough. Let's get rid of him, and let's bring in this guy right here, which, by the way, has the formula for the interpolation. If you take this formula right here, and you make it correspond with the values we're using, which is reign, and I, which is the index. It's, to solve this, this would be y equals y1 plus this part right here, which is the difference of the y's, the differences of the x's, and then the x minus the actual x value minus the x1 index. Well, in reign terms, it's reign of I minus 1 plus reign of I minus reign of I minus 1 over I minus I of I minus 1, which, by the way, is 1, times x minus I minus 1, which is the index before it. All right, let's run that one. Okay, run it. Okay, let's enter 0.15, and if we do that, it says the reign at x 0.15 is minus 0.006. All right, so something in here is not right. Let's see, I think I did something in my copying here, but that should actually be a key in because you always want to check the values. 0.15 should come up here with the reign being somewhere in this range right here. So first thing to look at is the x and the r. So in other words, what's happened? Let's trace it and see if we can figure out what's going on here, because that's something that's important that you need to be able to do. So you input an x, and the x should be, oh, I know what I did here. Let's go with not 0.15. That actually did do it right, because 0.15 would have been a number that was below. It's too small. In other words, I didn't take into account the border case of 0 to 0.04. But let's do this again, and let's put in a number like, let's see, 1.5. Well, if I do 1.5, okay, that should be a number between, this is 0, this is 1, this is 2. 1.5 should be between 0.04 and 0.11. Now, if you notice, you did not get a number between 0, between 1 and 2. You got a number 0.004, which is between here and here. Well, what does that tell you that you've got? What it should tell you is that the numbers are skewed to the left. In other words, your indexing is skewed. Well, that's kind of important because that allows you to debug how your interpolation is working. Now, we're going to go through something that's really important for you to be able to do, which is the concept of tracing. Well, first thing that I'm looking at here is you notice that the I went from 1 to 6. Well, we're not really going from 1 to 6. We're going from 0 to 6. Let's first change that to 0 to 6 because it's obvious that if you want to start at 0. Now, but why start at 1? Well, the reason is that, and let's show you. Let's not start at 0. If you start at 0, okay, well, the first calculation is reign of I minus 1. Now, if you were running this and that if condition was never tripped, let's say you put in 2.3, well, if you put in 2.3, you're not going to throw an exception because if you actually ran this with an I of 0 and you tried to do 0 minus 1, you're doing reign of minus 1. Well, reign of minus 1 is not a valid index, so that's still not going to work. Okay, so it does need to start at 1. Okay, that figured it out, got it solved. Now let me go into another common thing, now which you can actually do by tracing. So now we're going to start at reign of 1. Well, reign of 1 is 0.04. Well, the first thing that we're doing is we're looking to see if the I is greater than the X value. So in other words, if this I is greater than X. So if you go to the first one and you say, well, I is starting at, well, say X is 1.5. You started if I is 0. Well, I started if I of 1. Is 1 greater than X? No. Okay, well, if I is, in that case, you got, okay, well, that you know it's definitely not going to be greater than 1. Then you've got to move on to the next one, which is going to be 2. Well, if you go 0, 1, 2.11, okay, which you don't care about that, but that's the 2. If you had entered 1.5 in the I, well, the I is 1.5. The 1.5 is, oh, sorry, the 1.5 here is less than the 2 that's there, and it should go into here and actually do that with an I of 2. So how do you solve something like this? Okay, well, first is you got to be able to visualize it. How do you do that? Right there. Let's look and see what the I is. Print it out. Okay, so now you're going to run it. Okay, we're going to enter 1.5. We enter it, and you notice that it did say that the value of I when it came in here to the calculation was 2. All right, so we know that the I here is 2. So now you've got reign of 2 minus 1, which is I of 1, which should be 0.4. Okay, and then you got reign of I, which is I of 2, which should be 0.11. Okay, so it should be between those two numbers. Again, how do you visualize the calculations? Simple. You print them. You actually get it as an output. Now, there's other ways to do this. There's console logging, which you do use a lot in JavaScript because that's the easiest way to do this. But the bottom line is to debug some of these simple calculations, you just simply need to know what the numbers are. So now we'll go and put I minus 1, I minus 1, print it out, which will be the next value that's printed, and then you can print reign of I. All right, doop-de-doop. Okay, we're going to do 1.5 is the X that's going in, and now we know that, okay, so now we know, if we look at this, it's going between 0.04 and 0.11. Well, 0, 1, 2, the reign of I minus 1 is the correct reign of I. The reign of 1 is the correct one here. So if we look at this calculation here, we can say that the reign of I minus the reign of I minus 1 should be 0.11 minus 0.04. So that side's good. I minus 1. Okay, well that itself is going to be, we can simplify that. We could actually print it out if it wasn't these values. But we can simplify that. It's 1. We can simply get rid of it, because you're dividing by 1. Well, dividing by 1 is simply going to be 1. So now you know that it's reign of I, okay, minus that one. But now, something doesn't look right here. Okay, let's go back to the equation. Okay, well, let's make sure. You start with that number plus that number. Now, at this point, you should be starting to see, you might be able to say it, well, we know that X is 1.5 minus I minus 1, which is 2. So 1.5 minus 1 should be 0.5, so it's divided by 0.5, so this should be actually the same as multiplying by 2. So the difference should be multiplied by 2, which should, by the way, make sense. Let's run this again one more time. Whoops, syntax error. Let's see, I have invalid syntax. What did I do? I broke something. Oh, I probably broke something up here. Oh, I did. Now, in Thani, you got some help here. Bracket closes with that bracket. You see that bracket right there? I got an extra bracket right here, and now I fixed that. So let's run. Okay, let's do 1.5. Okay, rain at 0.15 is 0.075. Well, 0.04, 0.075. So the mistake was in the denominator portion of what I did. And what that was, and I actually know what the mistake was. If I was going to show it to you, I needed to do I minus 1, which I had not put my parentheses in the correct spot, and it was doing the calculation wrong. By the way, this is the correct answer. 1.5, 0.075 is the split, the difference between this. So now if I ran it one more time, and I wanted to interpolate something that was a little bit more complex, let's say like 2.3, well, 2.3 says it's 0.2569. Well, let's look at that. 0, 1, 2. So it's going to be between 0.11 and 0.6. And it should be about 0.3 all the way over, which does make sense. 0.26 should be about the third of the way between 0.11 and 0.6. I got some good numbers there. So what I've demonstrated here, Thani, interpolation, arrays, troubleshooting, debugging, and output. Once your equations are good, you can simply get rid of those guys. You don't need them anymore. So bye-bye they go. You run it, you've got a simple input, and voila, you got a simple output. Now notice my simple output has got a whole lot of decimal places, but that's going to be saved for yet the next one. I know, it was a lot to cover and a little bit of time and very fast. You can watch it over and over again. You can look at the code. You can do this. Here's where you're going. You just did a simple interpolation where the x values were the indexes of the array. But what about when you've got x values that are not integer indexes and y values, and you've got to interpolate between this x and this y? It's still doable. Hint, take the x, if you're given the x, go backwards, calculate the index, take the index, go forward, and calculate the y. And that allows you to interpolate between a non-integer index x and a non-integer index y, or a variable y. And they can both be in arrays. And this is, by the way, called parallel arrays. It gets more complex. Learn this. You're doing great. Great programming. I hope this helped. On.